Hello everyone, so today I'll be discussing question number 34 of GATE 2016 set 2. Consider the structural system shown in the figure under the action of this weight W. All the joints are hinged. The properties of the members in terms of length, area and modulus of elasticity are also given in the figure. Let L, A and E be 1 meter, 0.05 meter square and 30 into 10 raised to the power 6 Newton per meter square respectively, and W be equal to 100 kilonewton. Which of the following sets give the correct value of force, stress and change in length for horizontal member QR? So we need to find the force in this member QR, stress and finally the change in length. 4 options are given to us. It's a 2-mark question. For this type of problems, you can refer to lecture series on strength of materials by Professor S.K. Bhattacharya, Department of Civil Engineering, IIT Kharagpur. Let's start with the solution of this problem. So this is the structural system which is given to us. Since this applied load W is equal to 100 kilonewton, therefore this reactive force here, which will be in the upward direction, will also be equal to 100 kilonewton. Okay. So first of all, let us assume that every member is in tension. So every member is in tension here. Now let's start with this joint S. So let me separately draw this joint S. So here is the applied load, which is 100 kilonewton. So this force here is FSQ and this force is FSR. So let's call this as theta. So it is 45 degree here and 45 degree here. So this, since both of FS member SQ and SR at the same angle, and therefore FSQ will be equal to FSR, that is both the member will carry the equal forces. Now we can satisfy the vertical equilibrium here. So summation of force in vertical direction to be 0. So we can write that FSQ cos 45 degree plus FSR cos 45 degree is equal to 100 kilonewton. From here we can also write that since FSQ is equal to FSR, so we can also write that 2 times of FSR cos 45 degree is equal to 100 kilonewton. From here we get the value of FSR as 70.71 kilonewton. So now we have the value of FSR, then FSR equal to FSQ. So we also know the value of FSQ as FSR and it is equal to 70.71 kilonewton. Now if we see this joint, that is joint P, then we notice that here also we have this 100 kilonewton similar to this W load here. So here also these two forces will be equal to 70.71 kilonewton, like we saw it for FSR and FSQ. So here it will be 70.71 and here it will be 70.71 because this P joint has same loading as like joint S, right? So now we know all the forces. We know FPR, FPQ, FSQ and FSR. The only thing we don't know right now is this, that is FQR. Let us solve for this joint R in order to get the value of FQR. So if we draw this joint R here, so let's call this joint as joint number R. We know that this force is 70.71. This force is also equal to 70.71. There is also one more member here, that is FQR. So here also we have assumed the force initially to be tensile, so FQR. Now this angle is 45 degree given, and this angle is also equal to 45 degree. Now we can use the equilibrium condition as summation of force in horizontal direction to be 0. If we do that, we get FPR, which is the 70.71 cos 45 degree plus FQR plus FSR, that is the 70.71 FSR cos 45 degree equal to 0, right? We know FPR, we know FSR, so we can write 70.71 cos 45 degree plus 70.71 cos 45 degree equal to minus of FQR, right? From here we get the value of FQR as 100 kilonewton, minus 100 kilonewton. So initially we have assumed forces to be tensile in FQR. So negative sign indicates that FQR is a compressive force. So 100 kilonewton we can write in the bracket compressive, right? So this is the answer we got for FQR. So in our problem we were asked to find the value of force in member QR. So we got our answer as 100 kilonewton. So 100 kilonewton is given in both option number C and option D. In order to confirm the option, we need to solve it further. If we notice that in both in option C and D, the force and stress are same. The only thing is this shortening and extension part is different. So we can get our answer here only. How? Because since it is a compressive force acting in QR, so the length must get shortened, not extended. Okay, so so here only we can get our answer. That answer is option number C. But still let's find out the value of stress and this shortening also. So here if we want to find out the value of stress in member QR, so stress is force divided by area, right? So force, we know that it is 100 kilonewton, and what is the area? Area for this member is 2A, and the value of A is 0.05. So it will be 2 multiplied by 0.05 in meter square. So we get the value of stress in member QR as 1000 kilonewton per meter square. So this is the second part of this problem, that is stress is 1000 kilonewton per meter square. The final thing is shortening or extension. Of course it's a compressive force, so there will be shortening. So to find the value of shortening, we will use this formula. So delta L will be equal to PL upon AE. So it will be delta L. What is the value of force in this member? 100 kilonewton. So since E is given in Newton, so let's convert it into Newton. Length of this member is √2 times of L, that is 1 meter. A value is 2 into 0.05 because it's 2A actually, and E is given to us, the value of E is 30 into 10 raised to the power 6. So it is 30 into 10 raised to the power 6. From solving this, we get the value of delta L as 0.0417 meter. So this is the final answer we got for delta L. So from this, the correct answer is option number C. Compressive force 100, stress 1000 and shortening 0.0417 meter.